Hey, how's it going, everybody? Today we are looking at scale factor. So, what is scale factor? All right. Well, scale factor is something when, let's say, in a real life type of situation where you have a model or drawing of something. If you're going to propose that you want a building done, you're not going to go out and actually do the building right off the bat. You're going to do like a scale or a model of it. You see this a lot with maps, like for map reading. So you'll see this in geography. Um, you may also see it in science, but it's definitely something that's along the lines of engineering. So there's a lot of STEM type of activities that can be done with this. One of the projects I've done in the past is we'll take like a candy wrapper, usually something that's rectangular like Skittles or M&Ms, and then the kids will break it into sectioning it off, and then we'll enlarge it. All right, so this kind of goes along with your geometry too when you're talking about terms like enlarging, dilating, things like that. So we'll take a look at scale factor and how that works with some shapes and some word problems. This definitely has a real world application to it. Engineering, all that. I remember taking architecture in high school, and it definitely was applicable to that. So I hope you find it interesting. Leave a comment below, subscribe, all that fun stuff. It'll help me out. All right, thank you. All right, let's take a look at scale drawings and scale models and how scale factor applies to this. All right, so what we're going to do is we're going to write a ratio of one of the dimensions here. So if you look at this first problem here, we can see that we have the length provided for the actual room, which is here, and then the blueprint. So if you're not familiar with the blueprint, that's kind of like a plan of what you want to have drawn out, okay? So what we're going to do is we have the option, since we have two things here. We have the length and the width. We're assuming that they're drawn, they're similar shapes, as we spoke about in other types of activities. Personally, I would probably go with the length, only because you don't have to deal with this decimal here. So when we're writing the ratio, you're going to take one from the actual, and when I say actual, like what is actually going to be built. So the actual room is 144, all right? And then one from the scale drawing, which is the 18. All right, now we got to decide what's going to go on top. All right, we will always put the scale drawing or the scale model, and as I said, that's going to be your blueprint. So the 18 is going to go on top, the 144 is going to go on the bottom. Okay, now we want to see what our the scale is going to be. All right, so what we're going to do is we'll reduce that down if possible, right? So we'll see what's the largest number that can go into 18 and 144. Let's take a look here. So 18 can actually go into itself once, and it can go into 144 8 times. Now, what does this mean? You may have also seen it written like this if you've ever read a map before or done model planes and all that fun stuff. This means that for every 1 inch on the drawing, it's going to be 8 feet in actuality. That's what that means here. Okay. Now the second one down here on the bottom, we don't have an option. All right, so it looks like we can't avoid our the decimals. So we're going to set up our ratio again. All right, remember the top will always be our scale model or scale drawing, and in this case it's the toy car. So that might be the hardest part, deciding what's the scale model or drawing. So in this case it's the toy car. The 13.5 will go underneath, right? And in most cases you're going to get 1 on top. So let's see if 1.5 can actually go into 13.5, which I believe it can. All right, let's just check. So it does. So we'll divide by 1.5. So that gets us 1 on top, and it gets us a nice even number of 9 on the bottom. All right, so we have 1 to 9 for our scale factor there. All right, this is a very common real life problem. So I tell my kids a lot of times, you get into freelance photography, or even if you're like, when you eventually get married and you want to do something with pictures and get them enlarged, made into a poster or for a project, this is a great problem to look at. So it says a photograph was enlarged and made into a poster. All right, so we're dealing with the poster right now. The poster is 20.5 inches by 36 inches. So this will be our smaller side, and this is our larger side, and that's in inches. Okay. The scale factor is 1 to 5. Find the size of the photo. So with that being said, if we have a poster now and we're looking to see the size of the photo, our dimensions should be smaller. So what we want to think is that the poster is enlarged 5 times and the photo is going to be to 1. So it's a little backwards than what we're used to, or you could flip it, same thing. So with that being said, we're going to basically divide, all right? You need to know that you're going to get something smaller here. All right, so we can do 20.5 divided by 5, that's the scale factor. So we can say that our width is 4.1, right, still in inches. All right, and then the 36 will also divide by 5, which will be 7.2. It's hard to get the decimals, as we said. So the actual size is 4.1 by 7.2 inches, okay? Very common type of problem. You see this a lot in real life. All right, everybody, that was our lesson on scale factors, which also deals with scale models, scale drawings. So you might be asking yourself, when will I ever use this in real life? You know, you guys ask that all the time. Well, like I said, you may not have to go into engineering to deal with this, but there will be a point where you might need something to be enlarged, shrunken down, if something doesn't fit. I know as an adult, when you do home repairs, a lot of people do it themselves, both guys and girls now, all right? So especially with these YouTube videos, no pun intended here, a lot of people do things themselves. So you will be able to apply this somewhere along the lines in real life, or you know, if you ever decide to build your own home and you have to read the scale, that's something you're going to want to make sure you're familiar with. All right. So I hope you enjoyed it. There's so many real-world applications with this. I might actually even do like a follow-up because architecture and engineering is a really cool facet of math and science. But leave a comment. I hope it was very helpful for you, and enjoy the rest of your day.